GMAT all day.
For this last remainder problem, let's take a look at a problem where we sort of have to combine our algebraic translation skills for remainders with being able to find patterns and generate a lot of numbers. And so this problem here says, what is the remainder when positive integer x is divided by 6? And so if we're dividing by 6, it might seem like, just based on the question itself, that there are infinite possibilities for what a remainder could be, because there are infinite possibilities for what x could be. But remember, we are always restricted to what our remainders could be. And so here, if we're dividing by 6, we know our remainder can only be 0, 1, 2, 3, 4, or 5. And so we only have 6 options to start. Even though x can be anything, our remainders cannot be anything. So other than that, there is not much we can do. Here I actually might delete my data sufficiency answer choices, which again should not be a problem because you should have these memorized, just to give myself some more space. Okay, so let's see if we can translate each of these statements. So statement 1 says when x plus 3 is divided by 3, the remainder is 2. And so here they're saying not x, but x plus 3 is equal to 3, and we'll say our quotient, we'll just say y. So 3y plus 2, which means x, because ultimately we just care about x, should be equal to 3y minus 1. So if we wanted to generate a bunch of values for x, we should be able to do that here. So if we start with when y is equal to 1, so x is equal to 3 times 1 minus 1, which is 2. Then when y is 2, x would be 3 times 2 minus 1, so that would be 5. So it looks like we're going up by 3 each time. So here are some possible values for x. So if we want to know what the remainder is when we divide by 6, let's see what we get. So 2 divided by 6, that would be 0, remainder 2. 5 divided by 6, that would be 0, remainder 5. 8 would be 1, remainder 2. And so it looks like we have a pattern here, alternating between 2s and 5s. Here would be 1, remainder 5. 14 over 6 would be 2, remainder 2. 17 over 6 would be 2, remainder 5. 20 over 6 would be 3, remainder 2. 23 over 6 would be 3, remainder 5. So here in statement 1, it's insufficient because there's more than one option for what our remainder could be. But note that we only have 2 options here. So we narrowed down our options from 6 all the way to 2 just with this first statement. So if you're sort of thinking ahead, if I had 5 seconds left on my test, I would probably guess C as my answer, because it doesn't look like we need that much more information to get a single remainder. This first statement by itself, cut our possibilities down by a factor of 3. What about our second statement? So this says when x plus 5 is divided by 4, the remainder is 2. And so here we're saying not x, but x plus 5 is equal to 4. And we have a different quotient here. We don't necessarily know they have the same quotient. So we got to say x plus 5 is equal to 4z plus 2, which means x would be equal to 4z minus 3. If we were to do the same thing, so if this is x1, meaning this is the x from our first statement, what values for x do we get from our second statement? So x of 2 here. That we want to find again some possible remainders. So when z is equal to 1, x is equal to 1. When z is equal to 2, 4 times 2 is 8 minus 3, so x would be equal to 5. So we're going up by 4 each time. So 1, 5, 9, 13, 17, 21, 25, 29. That should be good for now. So let's find what some of our remainders could be. So 1 divided by 6 is 0, remainder 1. 5 divided by 6 is 0, remainder 5. So already that's enough to say insufficient, because we got 2 different remainders here. Let's keep following this pattern, or let's keep seeing if there is a pattern to our remainders. So 9 divided by 6 would be 1, remainder 3. We got a weird pattern here so far. 1, 5, 3. 13 divided by 6 would be 2, remainder 1. 17 divided by 6 would be 2, remainder 5. 21 divided by 6 would be 3, remainder 3. So it does look like we have a pattern, this 1, 5, 3 pattern. 25 divided by 6, 4, remainder 1. 29 divided by 6 would be 4, remainder 5. And so we want to just complete our pattern here. And one more number. 33 divided by 6 will be 5, remainder 3. So we already said our second statement is insufficient because we have 3 options for our remainder here. So why did I write out these long lists here? Why is it useful to be able to generate a lot of examples at one time? So what do we do when we look at our 2 statements together? So here, we just got to look at our values for x, but we can only use values that appeared in both of our tables. And so it looks like 5 works. And then what is the next one? 17 works. And so note in each of these cases, when x is 5, our remainder when we divide by 6, the remainder of 5. In each case here, when x is 17, we also had a remainder of 5. And so far it's looking like this statement may end up being sufficient. And I could generate some more examples here if I had to. Here as well, here we're going up by 4 each time, remember? So 23 to 29 looks like the next one. That also has a remainder of 5. But here I would probably stop and say this is sufficient. Anything else that looks like we get 41 looks like the next one. So 41 divided by 6 is what? 6 remainder 5, right? So it looks like together there's only a single possible remainder. And so this problem here is a good example of why you want to be organized when you're approaching these remainder problems. Don't be afraid to just sort of generate examples and then brute force your way through the problem. So 1 and 2 together were sufficient, right? Because there's only a single possible remainder, 5. So the answer is C. Those are remainder problems. It will not the highest yield of question type, but also not as scary as some people make them out to be sometimes. On to the next series of videos.